Welcome back to our channel. Today, we're diving into the most catastrophic events that have ever struck our planet. These aren't just stories of destruction, but tales of resilience, adaptation, and the extraordinary power of life to find a way forward. From ancient upheavals that reshaped the very atmosphere we breathe to cataclysmic impacts that ended the reign of Titans, we'll journey through deep time to uncover the events that have shaped the Earth we know today. Stay tuned, because you won't want to miss a single moment of this incredible journey through time. Our journey begins billions of years ago, in a world vastly different from our own. The continents were barren, the atmosphere was thick with methane and ammonia, and life was confined to the oceans, existing in single-celled simplicity. It was during this time in the primordial soup of the early Earth that a new form of life emerged, cyanobacteria. These tiny organisms possessed a remarkable ability. They could harness the power of sunlight to produce energy, releasing a byproduct that would change the course of life forever: oxygen. At first, this new gas was simply absorbed into the oceans, reacting with iron and forming vast rust deposits that we can still find today. But as the cyanobacteria flourished, the oxygen began to build up, eventually seeping out of the oceans and into the atmosphere. This marked the beginning of the Great Oxygenation Event, a pivotal turning point in Earth's history. For the anaerobic life forms that had dominated the planet for eons, this new gas was toxic. They had no defense against its reactive nature, and as oxygen levels rose, a mass extinction swept across the globe. The very air itself had become a poison, wiping out countless species and forever altering the trajectory of life on Earth. But from the ashes of this catastrophe, a new world emerged. The rise of oxygen paved the way for the evolution of aerobic respiration, a far more efficient way to produce energy. This, in turn, allowed life to become larger, more complex, and more diverse. The stage was set for the evolution of multicellular organisms, paving the way for the incredible tapestry of life we see today. The Great Oxygenation Event stands as a stark reminder that even the most catastrophic events can have unexpected and profound consequences. It was a period of immense upheaval and loss, but it also gave rise to the oxygen-rich atmosphere that sustains us today, a testament to the enduring power of life to adapt and thrive in the face of adversity. As life flourished and diversified, the Earth experienced periods of remarkable stability and growth. But this tranquility was not to last. Roughly 252 million years ago, life on Earth faced its greatest challenge: the Permian-Triassic extinction event, also known as the Great Dying. It was a cataclysm of unimaginable scale, a perfect storm of volcanic eruptions, climate change, and ecological collapse that wiped out over 90% of all marine species and 70% of terrestrial vertebrates. The very fabric of life on Earth was torn asunder, leaving behind a desolate and silent world. The primary culprit was colossal volcanic eruptions in what is now Siberia. These eruptions spewed out unimaginable quantities of lava and released gases like carbon dioxide, sulfur dioxide, and methane, creating a runaway greenhouse effect. The oceans became acidified, killing marine life on a staggering scale. On land, intense heat led to drought and wildfires. The Permian-Triassic extinction was a stark reminder of the fragility of life and the power of geological forces, yet life found a way. From the ashes, new species arose, filling the ecological voids left behind. The Permian-Triassic extinction serves as a chilling reminder of the potential for catastrophic events to reshape our planet. It highlights the interconnectedness of Earth's systems and the devastating consequences when those systems are pushed beyond their limits. Chapter 3. The Chicxulub Impact: Death from the Skies. For millions of years following the Great Dying, life on Earth slowly rebuilt, diversifying and evolving into a dazzling array of forms. The dinosaurs, once small and unassuming creatures, rose to dominance, ruling the planet for over 180 million years. Their reign, however, would come to an abrupt and catastrophic end 66 million years ago with a deafening roar that echoed across the planet. The culprit was an immense asteroid, estimated to be 6 miles wide, that slammed into Earth near the Yucatan Peninsula in what is now Mexico. The impact, now known as the Chicxulub event, released an unimaginable amount of energy, equivalent to billions of atomic bombs detonating simultaneously. The immediate aftermath was apocalyptic. The impact triggered earthquakes that shook the planet, causing widespread volcanic eruptions and tsunamis that ravaged coastlines. Millions of tons of molten rock were blasted into the atmosphere, raining down on the planet in a fiery inferno. But the true devastation came in the days and weeks that followed. The impact released so much dust and debris into the atmosphere that it blocked out the sun, plunging the Earth into a prolonged period of darkness and cold. This impact winter wreaked havoc on ecosystems, causing widespread plant die-offs and collapsing food chains. The dinosaurs, despite their size and dominance, were ill-equipped to survive such a cataclysm. Their reign, which had spanned over 180 million years, came to a sudden and dramatic end, along with an estimated 76% of all plant and animal species on Earth. The Chicxulub impact serves as a stark reminder of the ever-present threat posed by objects from space. It highlights the vulnerability of life on Earth, even those species at the pinnacle of their evolutionary success. Yet from the ashes of this destruction, new opportunities arose. Chapter 4. The Toba supervolcano eruption, a species on the brink. Our own species, Homo sapiens, has walked the Earth for a relatively short period, a mere blip in geological time, but our journey has been far from uneventful. Around 74,000 years ago, our ancestors faced a catastrophic event that nearly wiped us out, leaving our species teetering on the brink of extinction: the eruption of the Toba supervolcano. Located in present-day Sumatra, Indonesia, Toba erupted with a force rarely seen in Earth's history. It was a super eruption, the largest known explosive volcanic eruption in the past 2 million years. The eruption ejected an estimated 2,800 cubic kilometers of volcanic material, blanketing Southeast Asia in a thick layer of ash and spewing massive amounts of sulfur dioxide into the atmosphere. The immediate effects on the surrounding environment were devastating. Pyroclastic flows, fast-moving currents of hot gas and volcanic matter, incinerated everything in their path. Ashfall choked out vegetation, and the sheer volume of material ejected into the atmosphere plunged the planet into a volcanic winter. Global temperatures plummeted, perhaps by as much as 3 to 5 degrees Celsius, disrupting weather patterns and causing widespread environmental chaos. The impact on early human populations was profound. Genetic evidence suggests that the Toba eruption caused a severe population bottleneck, reducing the number of our ancestors to perhaps as few as 3,000 to 10,000 individuals. This near-extinction event had a profound impact on our species. It is thought to have led to a genetic bottleneck, reducing human diversity and shaping the course of our evolution. The Toba eruption stands as a stark reminder of the precariousness of our existence and the powerful forces that have shaped our species. Chapter 5. The Younger Dryas Impact Hypothesis, a Cosmic Interruption. As humans emerged from the shadow of the Toba eruption, they began to spread across the globe, their cultures and technologies evolving alongside them. Around 12,900 years ago, just as the last ice age was receding and the planet was warming, a sudden and dramatic shift in climate occurred, plunging the Earth back into near-glacial conditions. This period, known as the Younger Dryas, lasted for approximately 1,300 years and had a profound impact on the development of human civilizations. The cause of this abrupt climate shift has been a subject of intense debate among scientists. One of the most intriguing explanations is the Younger Dryas Impact Hypothesis, which suggests that a comet or asteroid, perhaps a fragmented one, collided with Earth, triggering the Younger Dryas event. Proponents of this hypothesis point to evidence of widespread fires, melted glass, and nanodiamonds found in geological layers dating back to the beginning of the Younger Dryas. These materials, they argue, are consistent with a cosmic impact event. The impact, if it occurred, would have had devastating consequences. Wildfires would have raged across continents, releasing massive amounts of soot and smoke into the atmosphere. The impact itself, along with the subsequent fires, could have melted glaciers and disrupted ocean currents, leading to the abrupt climate change observed during the Younger Dryas. Utro, a legacy of catastrophe, a future of resilience. From the oxygenation of the atmosphere to the extinction of the dinosaurs, from the near extinction of our own species to the enigmatic Younger Dryas event, Earth's history is punctuated by catastrophic events that have reshaped the planet and the life it supports. These events, while often destructive, have also been catalysts for change, driving evolution, shaping ecosystems, and ultimately paving the way for the world we know today. As we look to the future, it is important to remember the lessons of the past. Earth's history is a testament to the power of life to adapt and thrive, even in the face of unimaginable challenges. But it also serves as a stark reminder of the fragility of our planet and the importance of understanding and mitigating the risks we face. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon so you never miss an update. Let us know in the comments which catastrophic event you found most fascinating. See you next time.